The steering robot has been designed and developed by Anthony Best Dynamics as a tool for testing the transient handling behaviour of vehicles. It is currently being used by several makers of cars, trucks, tyres and power steering systems in Europe and the United States. It applies highly repeatable input motions to a vehicle's steering column. During a test, the torque applied to the steering wheel and its position are measured with high accuracy, and measurements of the resulting behaviour of the vehicle can be recorded at the same time. Several types of test are built into the controlling software, including those specified by the ISO 7401 document covering the transient lateral testing of vehicles. In addition, we may be able to incorporate your own custom tests into the software. Two versions are currently available. The full SR30 has comprehensive data capture facilities. If you already have your own complete data capture system, you may not need all the channels supplied with the full system. In that case, we can supply a simplified version known as the SR30 Lite. The Lite can be run from a laptop PC, and the rest of the hardware is then much more compact. This view shows the mechanical essentials of the robot. The steering wheel is replaced by a motor unit, itself fitted with a steering wheel. The motor drives the steering column directly, without any gears or belts. The only custom part required for installing the robot is a hub adapter splined to suit your steering column. A start-stop box can be placed within convenient reach of the driver. As an option, we can supply an adapter to allow you to use your existing steering wheel with a motor attached above it. The motor torque reaction is applied to a parallel linkage, which allows small eccentricity in the column motion as it turns. The parallel linkage is attached to a pneumatic strut that reacts the torque to the vehicle body. The strut is positioned between the windscreen and the floor and held in place by a combination of suckers and internal air pressure. The motor is a DC servo motor. The system shown in this video, the SR30, is fitted with a motor with a maximum torque of 30 Newton meters, but other torque options are available. Position feedback is from a high-resolution optical encoder. Power for the motor is supplied by a DC to DC converter connected to the vehicle battery. The battery provides power for the whole system, so that you do not need to install any ancillary supply. In the full SR30 system with data capture, the computer system includes a keyboard and a separate touchscreen instead of the normal monitor. The screen is clamped to the torque reaction structure. The keyboard is used in the normal way during data input, test specification and so on, but during testing it is more convenient to use the touchscreen. Some additional control and override functions are provided by the joystick. The computer functions and instrumentation amplifiers are all accessed via the front panel. The motor torque is measured using two force transducers, one in each of the horizontal links of the parallel linkage. The system provides a plus or minus 10 volt analog output of both the torque signal and the motor's angular position, which is derived from the signal from its optical encoder. Digital signals are also available for triggering your own equipment. The full SR30 system, the one shown, also provides up to 28 spare analog channels for your transducers, so that you can also measure vehicle roll, lateral acceleration and so on. The whole system can be installed in a vehicle in less than an hour. The computer system uses Windows software. Details of vehicles and tests carried out are stored in a database. Here we see the general data for a vehicle. Most of the types of tests that can be performed allow you to specify their parameters. Here we see the parameters for a continuous sine input. And now the test itself. As well as the continuous sign, tests include a single sign, that is, a lane change manoeuvre, frequency sweeps, and various pulses, which correspond to manoeuvres to change a vehicle's heading. In all cases, the software imposes some constraints to stop you specifying inappropriate values. In addition, an excitation profile can be taught to the system by manually turning the wheel. The computer captures the profile, and the robot reproduces it accurately. As mentioned earlier, if you require some other type of test, we will be willing to discuss your requirements. The computer does not have to be connected to the robot for you to set up the test program for a vehicle, and the process can be speeded up by copying test specifications from one vehicle to another. A mouse can be connected for use in the lab. Before the run is started, the test is chosen from ones set up for the vehicle. The vehicle is driven normally until a test is started, after which the driver still controls the throttle, gearbox and brake. He initiates the test by pressing the start button, then brings the vehicle to the correct speed and heading. When he moves his hand to the joystick and holds down its button, the motor is energized. The playout starts when he touches the start button again. The test can also be started with a start-stop box. During the test, this one is a frequency sweep, he can still adjust the mean path of the vehicle to correct for any drift using the joystick, without interrupting the test. If he wants to disconnect the input to the robot, he simply releases the button on the joystick and takes over full control of the vehicle. During the test, several parameters are displayed in real time on the computer screen. The three large digital panels show steering wheel angle, elapsed time, and another channel you can choose when setting up the test. The four large bar charts display the steer torque and three other quantities chosen by you. The peak values reached are displayed, as well as the instantaneous ones. Also, the bar color changes to red when a preset target level is exceeded. The smaller bar chart shows the joystick angle. At the end of the test, the driver releases the joystick button and stops the vehicle. You can examine the results before deciding whether to keep them or not. If you want, you can examine the results from the present test and from one previously stored as well. A range of charting functions is available to you. You can plot any variable against any other. Here, steering angle is plotted against time. You can zoom into a segment of a graph and then calculate the slope over the segment. You can plot multiple charts on the same screen. To do this, you choose from templates of graph layouts you have set up beforehand. Safety has been a primary consideration in the design of the robot and its operating procedure. As we have already described, the joystick button must be kept depressed for the test signal to be applied. Also, you can press any part of the screen which will stop the test playout in a controlled way, after which you can still steer with the joystick. Finally, in case of emergency, you can press the large red emergency stop button on the control box front panel or the stop button on the start-stop box. The Anthony Best steering robot is the ideal solution if you need to investigate the handling of vehicles with maximum versatility, accuracy and safety.